So the next question is, what happens when we have triangles that aren't triangles that we can use the law of sines for? Well, that's where the law of cosines comes in. I'm not going to drive the law of cosines, but I will put a video up so that if you want to look at it, you can. The law of cosine can be used to solve triangles in the following cases. Two sides and the angle between them are known, so side, angle, side, and or three sides are known. So I'm going to label this triangle over here. So we have triangle A, B, C. So this would be A, little b, and little c. So for the law of cosines, if we have angle C, or if we're solving for side C, so c squared is equal to a squared plus b squared, but that's not completely true. So notice that that's actually using the Pythagorean theorem right there. C squared equals a squared plus b squared, but we can only use the Pythagorean theorem when we have right triangles. So the rest of this is minus 2 times those side lengths AB, and then the cosine of the angle that's opposite to the side you are solving. And again, I'm not going to show you the derivation of this. If you want to see it, you can look at the extra video that I'm going to add. So if I wanted to solve for side length B, B squared is then equal to, so it would be the other two sides. So for this one, B squared equals C squared, or A squared plus C squared. Let's write it in order. So A squared plus C squared, kind of like the Pythagorean theorem again. But again, there's no hypotenuse here because it's not a right triangle, so that's why we have to write minus 2 times those two side lengths times the cosine of the side opposite, or the angle that's opposite that side, so of B. Go ahead and take a moment to see if you can solve for a squared and write that on your own. So a squared would be b squared plus c squared minus 2bc times the cosine of a. So those are our formulas. They're really all just the same. It's just depending on what side you're solving for and what angle. So there is a side strategy. Always use the largest angle in setup to avoid ambiguous case when changing to law of sines. So again, we haven't talked about the ambiguous case, but it is an issue. So whenever you're doing the law of cosines, you can then switch over to use the law of sines. But when you do, it's really important that you use the largest angle. Otherwise, you could end up with something that's not correct. So just keep that in mind. That's something that we're going to do as we solve these problems. So let's go ahead and look at these examples here. So first we have a side example, next one side angle side. So let's go ahead and look at the information. If we have side, and we want to solve for an angle, we can pick one. So it doesn't really matter. So you could pick either to solve for A, B, or C, doesn't really matter. Let's go ahead and just pick B. So if we were solving for angle B, that means that 19 is across from angle B, so 19 squared is equal to 1/2 the other two side lengths, not 1/2, I'm sorry, times the other two side lengths squared, so 8 squared plus 14 squared. I was thinking of area for a second. And then we have minus 2 times those two side lengths, 8 times 14, times the cosine of that angle. So again, we're doing the cosine of B. So the hard part for solving the law of cosines for students is usually the algebra. So we're going to go ahead and solve this out together. So 19 squared is 361 equals 8 squared, which is 64, plus 14 squared, so that gives us 260, minus 2 times 8 times 14 gives us 224 times the cosine of b. Then the next step would be to subtract 260. Usually students get this part wrong because they try to take the 260 minus the 224, which you cannot do because, again, the order of operations, doing PEMDAS backwards. So you want to get rid of things add or subtracted to what you're solving. So that's the 260. Then you get rid of things multiplied or divide, which is a negative 224, and then do everything else. So keep that in mind when you're solving. Often I see students try to do the 260 minus 224, which is incorrect. So we have, when we subtract that, we get 101 is equal to negative 224 cosine of b. So the next step would be divide both sides by negative 224. And again, don't write the decimal answer. We want to leave it in exact form when possible, so that way we get a more exact answer in our calculator. So I have the cosine of b is equal to 101 over negative 224. How do I solve for angle B? So if you recall, last year we talked about solving for angles. To get the angle out of the cosine, you have to use the cosine inverse, because remember the inverse switches your x and your y's. That's the only way we can get it out. So that means for this, we get the cosine inverse of 101 over negative 224 is equal to b, because that allows us to switch it when we use the inverse. Now in my calculator, I'm going to plug it in and round my answer when I'm done. So how do I get the inverse? Second cosine, we have 101 divided by negative 224, enter, and we get b is equal to, and I'm going to round to the nearest tenth, so 116.8 degrees. And now that I have this angle, now I have an angle and a side across from that. So to solve for angle A and C, I could use the law of cosines again if I want to, but usually students find the law of sines much easier because it's a lot less work. So we're going to go ahead and switch over. And notice that this would definitely be the largest angle. So that's why I actually picked B when I was solving, because I could tell that was the largest angle that we have here. The largest angle is always opposite the largest side. So for this, we did good, and now we can solve using the law of sines. So the sine of 116.8 degrees over 19 is equal to, and it doesn't matter which one we pick here, so I'm going to go ahead and pick A, the sine of A over 8. So when we solve this, to solve for the sine of A, we just need to multiply both sides by 8, or you can cross multiply and you get the same thing. So 8 times the sine of 116.8 degrees divided by 19 equals the sine of A. Again, all I did was multiply by 8 on both sides to get rid of that. And so how do I solve for angle A? Well, just like we did over here, I have to use the inverse. So the sine inverse of 8 times the sine of 116.8 degrees divided by 19 is equal to A. And again, make sure you plug that like it is in the calculator. Don't round your decimals to the very end. So when I plug this in, I have the sine inverse, so second sine. I'm going to use double parentheses here. So 8 times the sine of 116.8, close that parentheses twice, divided by 19, close parentheses again, enter, and I get 22.1 when I round, so 22.1 degrees. So make sure, again, that you are labeling with degrees. And now that we have two angles, it's easy to find the third, because the third angle C is equal to 180 degrees minus 22.1 degrees minus 116.8 degrees. And when we do all that, we get 41.1 degrees. And now I found all the angles of my triangle. So again, we solved for B first because it this note. It always used the largest angle in the setup to avoid the ambiguous case when changing to the law of sines. So this was the largest angle because this is the largest side. So if you have side, 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 keep that in mind. So let's go ahead and solve the next triangle. For the next triangle, we have angle A, we have side B and side C. So that's side, angle, side example. So the first thing we can solve for would be angle A. Notice that if I try to solve the law of sines here, the sine of 115 degrees over A equals the sine of B over 15 equals the sine of C over 10. Notice that no matter which two I pick, there's always two unknowns. So if I picked these two to set equal, there's two unknowns. If I were instead to pick the sine of B over 15 equals the sine of C over 10, again, there's still two unknowns, the B and the C. What if instead I picked this to be equal to this? Again, there's still two unknowns. That is why we cannot use the law of sines. Same thing if I were to just set up the other problem. So that's why we have the law of cosines. So when I go ahead to solve this, we have the cosine of 115 is what we're going to be using because that's the angle we're given. So we're going to solve for side length A. So A squared is equal to 10 squared plus 15 squared minus 2 times 10 times 15 times the cosine of the angle across from the side we are solving, which is 115 degrees. So now I'm going to go ahead and solve. So a squared is equal to 10 squared plus 15 squared is 325 minus 2 times 10 times 15 is 300 times the cosine of 115 degrees. And this is nice because I'm not trying, unlike the other one, solve for the angle. I can just go ahead and plug that all into my calculator. So if I plug that into my calculator, we have 325 minus 300 times the cosine of 115 degrees, enter. So a squared is equal to 451.7854785. But notice we're not done because we have this square here. How do we get rid of the square? We have to take the square root. And normally you take plus or minus, but we can't have a negative length, so we don't need the negative here. So in my calculator, I'm going to do second square root. And if you hit second and this sign, negative sign right here, notice you get the answer. So I can hit enter, and that gives me 21.25. So that means length A, because we're doing the side length, we're going to round. So 21.26 because it's 255. So A is equal to 22.26. Now that I have that length, now I have enough to set up one proportion to use the law of sines, so I can go ahead and do so. Could you use the law of cosines again? Of course. So we have the sine of 115 degrees over 22.26 is equal to, and I'm just going to go ahead and solve for b next. So the sine of b over 15. Why don't you guys go ahead and solve this on your own on pause when you're done. So we get multiply both sides by 15 to get that from that side. So 15 times the sine of 115 degrees divided by 22.26 is equal to the sine of b. Of course, since we're solving for an angle inside the sine, the only way to get rid of it is using the sine inverse of 15 times the sine of 115 degrees over 22.26 is equal to b. So in your calculator, don't forget to use the inverse button by hitting second sine, which gives you the sine inverse. So when you do that, you get b is equal to 39.8 degrees, since we're doing an angle. So 39.8 degrees, and that means c should be easy to solve because c is equal to 180 minus 115 minus what we just found, which is 39.8 degrees. So that means that angle C is 25.2 degrees. And now we've solved for each different piece of the information or the triangle that was missing. So let's review the possible angle problems. So right triangles, if we have a right triangle, we can use right triangle trigonometry, so SOHCAHTOA, or the Pythagorean theorem, a squared plus b squared equals c squared. When it's not a right triangle, when we have oblique triangles, we are going to use either the law of sines or law of cosines. So if you have angle side angle or angle angle side, you can use the law of sines. Side side angle is also the law of sines, but this is going to be special cases, and we're going to do those problems later. Side 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 and side angle side are going to be the law of cosines, because if you were to try to solve again the law of cosines or the law of sines when it's a cosines problem, you'll see that there's not enough information like that one problem we did just a minute ago. So let's go ahead and solve each triangle below for the missing sides and angles. So for these, why don't you try to see if you can do these two on your own. When you're done, pause the video and check your work. So for this first one, we have side angle side. So side angle side means if we were to try to set up the law of sines, we wouldn't have enough information. So we can go ahead and solve using the law of cosines. So that means we're going to solve for the side opposite the given angle, which is c. So c squared is equal to 10 squared minus 6 or plus 16 squared minus 2 times 10 times 16 times the cosine of 110 degrees. So that means when we solve this, we get c squared is equal to, when you do all of this in your calculator, you get 456.446. That's a 9. I can't read my own writing. 9459. I might be a little off right there. So I just checked my work. So this is actually a 4. Sorry about that. And then of course we have to take the square root to get rid of that square in your calculator. Make sure you are finding the exact answer. So just real quick, another way you can do that is to do second square root if you have a newer calculator. And then you can just go up here and hit enter for the newer calculators. I don't know if the one on the computers do that or not. And you can get the square root that way too. Or again, you can do second and the negative sign uses the answer. So either way. So we get c is equal to 21.57. And now I can use the law of sines to solve because I have enough information. Of course, we're going to have some rounding error because side C is rounded. So the sine of 110 degrees over 21.57 is equal to the sine of b over 10. So for this one, multiply both sides by 10. So 10 times the sine of 110 degrees over 21.57 is equal to the sine of b. To get b out of the sine, we have to do the sine inverse. So the sine inverse of of 10 times the sine of 110 degrees over 21.57 is equal to b. So when you plug that into your calculator, don't forget the sine inverse key. So b is then equal to 25.8 degrees. And then, of course, to solve for angle A, 180 minus 110 minus 25.8 degrees gives us angle A, which is equal to 44.2 degrees. And looking at the next triangle, this one is a side, side, side. So again, law of cosines. And again, remember our note that we said earlier, you always want to pick the largest angle when solving, because then that way you avoid the ambiguous case. So the largest angle is always across from the largest side, so that means we're going to be solving for angle A first. So we have 20 squared is equal to 15 squared plus 8.3 squared minus 2 times 15 times 8.3 times the cosine of A. So I would always get in the habit of writing this out because often I see students get this problem wrong. So this gives me 293.89 minus 249 times the cosine of A. And then, of course, you want to subtract 293.89 first. When we do that, we end up with 106.11 is equal to negative 249 times the cosine of A divided by negative 249. And we get the cosine of A is equal to 106.11 divided by negative 249. To get A of the cosine, we have to use the cosine inverse, so A is equal to the cosine inverse of 106.11 divided by negative 249. And when you plug that into your calculator, you get A is equal to 115.2 degrees. Now I have enough information to use the law of sines to solve. So the sine of 115.2 degrees over 20 is equal to, and I'm going to do b first, so the sine of b over 15. If you didn't do the sine of b first, you might just have a slightly different rounding error by maybe a tenth or 100th point. So we get the sine of b is equal to, multiply both sides by 15. That cancels that out. So the sine of b is equal to 15 times the sine of 115.2 degrees divided by 20. So to get b by itself, you have to use the sine inverse. So b is equal to the sine inverse of 15 times the sine of 115.2 degrees divided by 20. Plug that into your calculator, and if you plug it in correctly, you should get 42.7 degrees. So that means that C is equal to 180 degrees minus 115.2 degrees minus 42.7 degrees, which ends up giving us 22.1 degrees. Two trains leave the station on different tracks. The tracks are at an angle of 125 degrees with the station at the vertex. The first train travels on an average of 100 kilometers per hour, and the second train travels at an average of 65 kilometers per hour. How far apart are the two trains after 2 hours? So now I would challenge you guys to pause the video here and take a second to see if you can make a picture of this and see if you can work it out, and then unpause it and I'll show you the answer. So here's our picture so far. So we have our station, and it says the two trains leave the station on different tracks, and they make an angle of 125 degrees with the station at the vertex. So that's why we have this picture looks like this. Then the other thing says we want to figure out how far apart are the two trains after 2 hours. So we're given that train A is traveling at a rate of 100 kilometers per hour and train B is traveling at a rate of 65 kilometers per hour. So if we want to find how far they are apart after 2 hours, we need to multiply each of these by 2 to figure out the distance that they have traveled. So this would be 200 kilometers per hour and 130 per 2 hours, I should say. So then I know that side B is going to be from the station to train A. So this one is a little bit harder. So from the station to train A has traveled 200 kilometers in 2 hours. And from the station to train B here, we have traveled 130 kilometers per the 2 hours. So now I want to figure out how far apart these are. So I'm trying to figure out this distance right here. So of course I have a side, the included angle, and a side, so side angle side, which means I can use the law of cosines. So in this case, this is side C, that's what we're trying to solve for. So C squared equals 130 squared plus 200 squared minus 2 times 130 times 200 times the cosine of the angle 125 degrees. So I'm going to do that all of my calculator, and then I'm going to take the square root of my answer. So for this one, I'm doing my calculator and then take the square root, you end up with 294.5 kilometers apart after 2 hours. So that would be our answer. So let's go ahead and do one more problem. So for this next problem here, we have a 100-foot tall antenna tower is to be placed on a hillside that makes an angle of 12 degrees with the horizontal. If it is to be anchored by 2 cables from the top of the tower to points 85 feet uphill and 95 feet downhill from the base, how much cable is needed? So see if you can pause the video and draw a picture of this, and then unpause it and we'll look at it together. So I'm going to start. First we have our hill. So this is my hill right there. Then it says that we know the hillside makes a 12-degree angle with the horizontal. So the horizontal would just be like kind of like thinking about the horizon. So this would be the horizontal. It's a horizontal line. So I know that from here to here, this is 12 degrees with the horizontal. Then it says that we have some antenna tower that is 100 feet tall. Pretend that's straight. So this is 100. And we know that we're going to place a cable 85 feet uphill. So from here to here, this is my cable. So this is 85 feet uphill. And then downhill, which would be this length right here, is going to be 95 feet. Now we want to figure out how much cable is needed. So we need to figure out this length here for the cable and the length at the top for the cable. So let's go ahead and just do a little bit of labeling. I'm going to call this B here. Let's call this C, and I'm going to call this D. So I'm going to call this B1, and then I'm going to call this B2. Now for this, we have a bunch of sides, but we don't have the angle included right here in order to solve for B1, and we don't have this angle right here in order to solve for B2 because you need a side angle on the side. So how can I find those? Well, if you think about it, I'm going to erase this B right here. If I were to extend this down, I know this is going to make a right triangle right here. So if that makes a right triangle, then I can figure out what this little angle in here is going to be by using my triangle sum theorem. So that angle in there is going to be, so we'll call that angle, I'm going to call this E right here. So angle measure of CBE would be equal to 180 degrees minus 90 degrees minus 12 degrees, which gives me 78 degrees. So if I know this is 78 degrees, then I can figure out what this angle is by using the supplementary angles postulate. So for this one, I can figure out what the angle measure of CB, and let's call this up here A. So this angle right here, by taking 180 degrees minus 78 degrees, which is 102. So I know that this angle measure right here is 102 degrees. And again, by the supplementary angles, I can figure out that this angle, by subtracting 180 minus 102, I know that this angle measure is going to then be 78 degrees right there. So now I have all the information I need in order to solve for B1 and B2. So for this, because I have a side, the included angle, and the side, I can solve for B2. So B2 is equal to, and actually let's do it as B2 squared. So B2 squared, the length would be equal to 95 squared plus 100 squared minus 2 times 95 times 100 times the cosine of 102 degrees. So if you plug this into your calculator and solve, you end up with B2 being about equal to 151 point, I'm going to round to nearest hundredth, 58 feet. And now I can go ahead and solve for B1. So the length squared would be equal to, because don't forget you have to take the square root of your answer after you plug it into your calculator. So B1 squared would be equal to 85 squared plus 100 squared minus 2 times 85 times 100 times the cosine of 78 degrees. So when I plug this into my calculator and then take the square root of it, B1 is about equal to, I have 117.01 feet. And if we want to find out the length of the cable needed, then of course the length of the cable would be B1 plus B2. So I'm adding these two answers that I just got together, which ends up being about 268.59 feet of cable is needed. And that would be my answer.